Hello, this is Group 11 for DFMA, and we have the Punch Master. My name is Joshua Virgil. For the agenda today, we're going to be talking about the design process of the Punch Master, the DFMA summary, recommendations for the design improvement, cost analysis, and the concurrent process summary.
And I'm Gage Petrock from the same group. This was the final design we ended up going with, as featured here. Next slide, please. So this was the original design we came up with. We kind of all pooled our designs and we're like, who's got the best one? And this is the one we ended up with. Well, this was the prototype of the design we ended up with, which is very simple, slide straight in, but it had way too much side action to get these little holes. And was blocky, didn't look good, not ergonomic, not usable. So next slide, please. So we came up to a little better looking of a design. It still came off of the two-part shell design, which we thought was the best idea to get the DFMA standards the lowest because 2 parts easiest. Not a lot of moving parts. We had to incorporate a battery door, which moves. Very simple, just a snap fit, pops right out, pops right back in. And then across the whole part, we have these locator pegs to locate the PCB. It can even be featured here on an empty case. A slot for the battery and a slot with guidelines for the display screen. There's even holes to attach Velcro straps, so that is completely mounted, don't have to hold it. Not even a handheld device. Next slide, please. And then here are our drawings, just giving you a basic layout of the dimensions of our parts and how we drafted them. And then next slide. And then here's it in action once again. Very simple Velcro straps, pops right on. And then featuring the buttons and stuff. Sadly, we don't have a battery in here right now, but on-off switch is right here on the side. Just very simple, on and off. And there's a button on the top here that simply click it and it activates the program so that you are ready to try out the Punch Master. Next slide. Oh.
So for our DFA concurrent costing, just some simple points here. There was some decently big discrepancy between our prices and the external prices. Mainly the tooling. We came to the conclusion that the biggest area was the side action that we could not get rid of on the top cover versus the bottom cover. That's why you see that $9,000 difference.
This is our estimated part cost. So we take the electricals, their bill of materials, their parts ran about $110. So we could drop that down to $55 if we buy in bulk. Our vendor estimate was almost $6 to create the structure of the part. So the bottom housing, the top cover, and the battery door. And then plugging it all into the DFMA software, I think deliverable 8, we found that the assembly cost was a little over $2, $2.24 actually. This takes into account all the different assembly steps and like everything from gluing the button and the switch to running the Velcro straps through the holes, things like that. So the estimated cost per unit is about $63 in mass production. So next slide. So this is our estimated sales and profits. We take that 63 number that we just got, how much it costs to make, and we subtract that from our the cost of the product. So we said we were going to charge about $80 per unit if we were to sell these. So that'd be a profit margin of about $17. Multiply that by our estimated sales, which is 5,000 units in the first year. This comes out to roughly $83,900, which would pay back our tooling within the first year. So these estimates were taken from a mixture of ChatGPT and just our own sort of understanding of how the sales work with sports facilities. Next slide. So, oh yeah, this is the concurrent design summary. So what went well in this project, we think we did pretty good with communicating with the electrical engineers, because the team working beside us with the other, like on the other side of the electricals, did not have as good a communication line, and we've seen a lot of issues they had that we were able to work around just by being in constant communication with them via email, Teams, and I think weekly meetings. So that went really well. Challenges for this project were definitely the 3D printing process. This material we used, was it ABS? ABS for all these prototypes. Some of the features were just a little too thin or a little too whatever the case, and they would break off sort of easily, so we had to go back and change the design to make some things more structurally sound, or just completely take out the effects of some things. So challenges were definitely learning the process as we were going. Would have probably been helpful to have a better understanding of 3D printing before we got into it. How these were addressed, like I said, we, with the challenge of 3D printing, we just 3D printed a couple times. I think we had 3 complete iterations of the thing, and we had maybe 5 or 6 different little parts that we were judging fitment with some of the electrical components. And this was going throughout the whole project. So we understood these challenges when we went in, and I think we addressed them fairly well as the project went on. So personal takeaways, this is the part where we tell you about what we'll remember in 10 years from this project. And I'll say, I will remember, if you want something done right, to do it yourself, because our electrical engineers sent us like 5 different dimensions for some of the parts, and we eventually just had to have them bring in the parts and calipers, and we measured them ourselves. All right.
So my personal takeaway that I had was it is a lot harder to reverse engineer your part to fit the injection molding standards that you want, rather than to think about those standards while you're designing the part.
My personal takeaway was learning how to set up the DFMA cost concurrent by myself originally the first time. Second time with the team, it was a lot more easy to understand, so I'll take that with me.
One thing that I can definitely take away with me is that the design process is very good to brainstorm with my team multiple times, so that not only we get the best ideas that we can for an individual part, like the part as a whole, but we can brainstorm over the little pieces that we kept having little troubles with. There were just little nicks that kept giving us a pain in the butt, but working together as a team, that definitely helped our minds pull the ideas better.
And I think that's it, yeah.
All right, guys.
Thank you. Let's all stand in the frame at once.
Okay, say your names.
Yeah.
Say thank you.
Joshua Virgil.
Max Harris.
Gage Pat Rock.
Ryan Champ.
Thank you.
Thank you.
Thank you.